working on my own wind turbine's custom charge controller. Unfortunately, I did not have much luck with this provided charge controller. It failed twice in a year. First year, I think those people who fixed, they put negative polarity and it just busted. And the next year I got it and I did the same mistake myself and it busted. So I decided to build my own. Aesthetically it looks very nice, but it's not properly labeled. If it had a good labeling, I wouldn't have done the same mistake twice. So my wind turbine is a 3-phase AC wind turbine mounted right on top of the mizzen mast. Its rated power is 960 watts. During very high wind conditions, I checked the turbine's line-to-line voltage. That is checking the voltage among two wires of the 3 AC lines, and I got 52 volts AC coming out of a pair of wires. So that is turbine's line-to-line voltage. The power factor as per the specification is 0.85 of this turbine. The first component in the system is putting a 3-phase brake switch. This is a blade knife switch used for other purposes, but I'm going to put a copper strip inside. So when I turn the switch, it will short circuit the 3 AC lines of the wind turbine. So by short circuiting all the 3 lines, it generates a negative magnetic field on the stator, which basically stops turning the wind turbine. The next component is a 3-pole disconnect or circuit breaker. Basically, it disconnects the AC current coming from the wind turbine. Physically, it's the same as the above brake system, but it has its own purpose. That is to completely disconnect it from the wind turbine. Next most important component is the 3-phase AC to DC bridge rectifier. It generates a lot of heats, therefore it is mounted on a heat sink. So this diagram shows internal working of a rectifier. Basically, it converts 3-phase AC into DC using 6 diodes. A rectifier will give me a DC current, but that will be slightly pulsating and I will need to smooth it out. Therefore, the next component is a smoothing capacitor, which is polarized. Polarized to basically take the DC input, store energy, and compensate for any fluctuation in the voltage drop and rise, and giving a very smooth DC output. So far so good. The next step is to calculate what kind of DC voltage and current will be coming out of the system. And for that, artificial intelligence Copilot has been very helpful. I gave the parameter and it did a calculation for me telling that I can expect 72 volts of DC and about 11 amperes of current coming out of the DC system. So for that, I am going to select a proper charge controller for the system. Based on this calculation, I checked Victron charge controllers and I picked up 120 MPPT solar charge controller. Basically, it can take up to 100 volts of DC and it can output 20 amperes of current, and it is configurable for 12, 24 or 48 volt system. So normally these smart charge controllers take smooth DC input from a solar panel array and regulate the DC voltage input and providing the DC output current for the system's voltage to charge a battery bank. However, in this case, it is unaware that if the DC is coming from a solar panel array or from a polarized capacitor. So I've already installed and configured a 48 volt system for my power generation on board. And the purpose of using this MPPT 120 charge controller is that I can do the monitoring. Even though on my monitoring panel it will think that it is coming from a solar array, but I know that this power is coming from my wind turbine. And there we go. Let's see. It's not just a proof of concept, but I'm confident that it will work.